Okay, interaction. Whoa, this is cool. Okay, nobody's online, which is fine. Okay, whew. All right. That should be plenty of time. And now we're going to talk about more abacus. Okay, we're going to talk about abacus. What are we doing? So what we're going to do is we are going to talk about the abacus. This abacus is counting. It's a counting tool. What's a counting tool? This counting tool just helps me count. Well, that's all we're doing. We're only counting. We're only counting on the abacus. What does that mean? Well, we do 1, 2, 3, 4. Just like we do that. You know the things that's common, right? This is common in this. The things that are common between these two is that this is a die, right? It has 4. We can see 4. Well, what do you see the notice? What do you notice? What do you notice the common thing? That this is 4. How do I know? Well, anytime these beads are touching this horizontal bar, that means it's counted. That's 4. These beads means that there's our 0. These are all zeros because they're not touching the horizontal bar. Good morning, welcome everybody, welcome. So just to show the difference, not the difference, the similarities. So if I did this, we know that this is 2. So if that's 2, then what does that mean? Well, where the heck is 5? Where is 5? 5 will always be this. That's what 5 is. Good morning, everybody. Good morning, good evening, good afternoon, good everywhere. Good day to everybody who is here. I'm not sure where everybody's coming from. Come on in, come on in. We're talking about the abacus, and abacus is a counting tool. You know, we use a die in kindergarten, and we don't use an abacus. So I'm just showing similarities of what the abacus is and what the die is. So what this means is we're going to be counting on the abacus. When we count, it's 1, 2, 3, 4, and then 5. This will always be 5. Anytime these beads are touching the 5, hello everybody, hello. Every time the beads are touching the horizontal bar, this beam, it's being counted. So if you're tracking that if this is 5 and this is 1, when I put it together, that is 6. And then that's 7, that's 8, and that's 9. So now we have 9. Now the difference is what? Well, we could say that this is 5, and then this is 5, and then this is 5, and then this is 5, and this is 5. So if all of these beads are touching this beam, this is 5, which is great, Now if we were to write it out, we want to know what? What do I want to know? I want to know, where is 10? What happened to 10? Well, if we look at it, and I can't find it anymore. I keep losing it. Okay. Anyways, so if this is 9, how do we know what 10 is? Good morning, good evening, good day, everybody. If I want to know what 10 is, well, if you notice, this is 9. How do I know that this is 9? Because if you see that there is a dot here, this dot tells me that my place value. Thank you so much for the likes. I'm trying to readjust my camera, and it's very bright. I'm so sorry. So here is the dot. This dot tells me that this is the place value of ones. Because it's a place value of ones, then what's after ones? We all know in 4th grade math, what are the place values? The place values is over here. So if this is my ones, this is my tens. So I call I move that, and that's now 10. So 10, 20, right? 10, 11, 12, 13, 14, and then 15, 16, 17. How do I know? These beads are touching this beam right here. So when they're touching the beam, that means that these beads are counted. So now we are at 17. We go 18, 19. Who would have thought you'd be counting on TikTok? And then we're 20. We have 21, 22, 23, 24. And then obviously this is 25, right? How do I know this is 25? Because the top bead will always be 5 no matter what. No matter what, the top bead will always be 25. So we're going to continue to count. I can continue to count to 26, 27, 28, 29, and then 30. So why are we talking about this? Because I'm just showing how to read the abacus. Because the first thing we have to do is we have to learn how to read the abacus before, thank you so much for the hearts, before we start going into adding, subtraction, multiplication, division, we need to learn how to read the abacus. When we learn how to read the abacus, then we can actually start going into into math. That's what it is. Abacus helps me with math. Abacus helps me with arithmetic. So, and what I like to say is abacus is the gateway to complex. gateway to complex math. Now, does it do calculus? No, it doesn't do calculus. But you know what abacus does? It lays the groundwork. It lays the foundation. It closes the gap on a lot of the things that we happen when we were learning in school. Right? So the first thing we're going to do is we're going to learn how to read the abacus. When we learn how to read the abacus, we can talk about, adding, subtracting. Or we could do it right now. It'd be super simple. Because why? We have 2 plus 2. Why do I have 2 beads? 2 beads here when I move it, right? It's just like... It's just like when we're using these bricks, right? When we count, and I have 2 beads, I'm not going to say 1, 2. I'm going to be like, this is 2. Same thing with the abacus. This is 2. So I'm going to add 2 more beads. That's 2 beads. So it's interesting to see, like, you could do quantity, but then it gets a little wonky because this is going to always be 5. This will always be 5 no matter what. So all the top bead, the way we say it, all the top bead is a value of 5. The reason why I say top bead and not the blue bead, because if we use a different abacus, there's no blue. There's no blue bead, right? But we know that this is the top bead and they all use the same. They are all the same. They're all the same way. They're all the same way. Hey, in CMS, how you doing? I was waiting for you. So we're going to continue on and hopefully we'll have enough time to do some multiplication. So, hey Sammy, how's it going? Welcome everybody. So what we're doing is we're learning how to count on the abacus. So the thought process was the top bead will always be 5 no matter what. In this abacus, right, we can't say blue bead because they're all brown. They're all brown. So if they're all brown, what are we going to say? Well, that's why we say the top bead. So this is 5 and this is 5. If we look at it, this will be 6, that will be 6. Not a problem, right? Not a problem. So as we continue to go, we have this number. Well, what number? I'm looking forward to seeing. Yes, I'm looking for multiplication. Hopefully we can get there. But I do have some questions. I have some multiplication questions prepped. So before I continue, with the simple counting, let me know in the comment what everybody thinks this number is. If this is the ones and this is the tens. Now, why am I using the ones over here? Because I have a dot, and this dot tells me that it is the ones place. I'm going to signify that this is the ones place. Yes, thank you, NCMS. Thank you so much. And so, again, notice that there's another dot over here. You could use this dot, so we could actually say that this is 16 right here. We could say that because I said that this was my NCM. This was my my ones place. So if this is my ones, I can choose that to be my 16. If this is my ones, I could choose this to be my 16. However, if I chose this to be my ones, then I just have a really great big number, right? So if you notice that the dot also helps signifies the grouping. What does that mean? Well, if I start writing it out, it'd be 1 6 0 0 0. Notice I have my ones, my tens, my hundreds, and my thousands. So I have a comma here. This comma doesn't take place. This comma doesn't take place from a place value. What it does is it shows you that this is the thousands, and then we have the 10,000. So does that make sense? So depending on where your dot is, depends on how big your number is. But, obviously with a bigger abacus, with a 13 column abacus, we have a lot more place values depending on where you want your dot be. So the dot actually it's not written in stone. I laugh because it's not. It's actually made out of plastic. So, yes, the dot is not written in stone. So it's not like it has to be this one and this one only. It actually depends on what you're trying to do, right? So if you have like a really big number, then you use a dot over here. If it's a really small number, then you can use a dot over here. But because we're on the 13 column, I like to be in the middle. I like to be in the middle because I like to, make sure that everybody is happy. Okay. So we're counting on the abacus. So we have 1, 2, 3, 4, and then 5. Thank you so much for the hearts. Thank you so much for the hearts. Okay, so we are still counting on the abacus, and we're going to just a little bit more. We're going to count, and then we're going to start going into adding and subtracting. So we have our 5, and then we 6, 7, 8, 9. So one thing is, I don't mind the brown. If the colorful one is overstimulating, the brown one is just as good. Everything is just as good. You can find it all. This one's a 13 column. This one is 7 columns. I started writing it out because I got tired of counting. Anyways, so you could do the 13 column one. They're all made out of plastic. I mean, the rare ones that are made out of bamboo are a little bit more pricey. So, okay, I'm going to continue on with this one because I like the colors, and I've been dealing with the brown one, the brown abacus, for the single color one for about more than 20 years. So I wanted to change it up a little bit, and I'm going to use the colorful one because it's also easier to see, right? Because it's anyways. But again, if this is overstimulating, then you can get the single color one. It works exactly the same. There is a multicolor one. There's a 13 multicolor one. That's a little much. I think depending on how old the children is, if there's 3, 4, and 5, it's nice to graduate them to the single colors. Just a thought. Okay, so we're going to talk about more. We're going to do a few more on place values, right? Because now we're talking about I was doing research. Now we're talking about 4th grade math, which is like talking about the place values. So we're going to understand place values and working with tens. So what we're going to do is we're just going to count. We do 100, 200, 300, 400. 400, how do I know? Because it's 004. When we look at it, we're now at the hundreds column. If I deem this as my ones column, this is my ones, tens, hundreds. So then I can do my 500. So that is 500. How do I know? Because the top bead is touching the horizontal bar. And I'm actually thinking in my head how to make a 4th grade abacus book. And it would be kind of interesting because I never thought it would be possible. But as I go through all these lives, and I want to appreciate everybody joining me, as I go through all these lives, it makes me understand like more and more how to make like abacus books specifically for the grades, which is quite interesting. Like it's quite an epiphany. Okay, so we have 500. How do I know it's 500? Because it's 500, and then this is 5,000, right? 5,000, 000, 5,000, 5,000, 5,000, right? So that's 5,000. So we understand our place values, right? If I give you a number, okay, in the chat, what number do you think this is? If I deem that this is my ones, this is my tens, this is my hundreds, and this is my thousands, everybody in the chat, let me know what number you think this is. Yeah, let me know in the chat what number do you think this is. So remember that the top bead will always have a value of 5, and it's easy. It's simple to use and easy to understand. I need to say that some more. So abacus is the gateway to more complex math. So let me know in the chat, what number do you think this is? 7,902. Exactly. Thank you so much for commenting. Okay, so that was just a little bit of a trying to figure out what the place value is. And so what we're going to do is we're going to do some adding. We're going to do some simple adding. Why is it simple? Because it's interesting how we see certain things. So in this book, the way I have it where I wanted the children to know what it would be like to add a specific number. Now, when I was noticing, because I was doing some research, there was a video that I was looking at, and the video was about how to add. And I was like, okay, great. How do they add? How do they teach children how to add? And I noticed that they're really focused on the result, whereas abacus is focused on the process. So one of the questions was 5 plus 3. So that was one of the questions on abacus on the thing, and they were like, "Oh, it's 8. Okay, fantastic. We all know what the number 8 is. That's what we're going to talk about more about the 8." And I'm like, okay. Now, why is this like it? Why am I going down this path? Because I wanted to show you that in school, I noticed that they focus on the result when they're small digits like this. But in abacus, we actually have more than just two add-ins. We do more. So we can't focus on the result. So on the abacus, this is what adding looks like. I have a 5, and then do I have enough to add 3? Yes. So all I got to do is add the 3. Great. Not a problem. And then the next question they said, okay, what is 1 plus 7? Okay, 1 plus 7 is 8. Okay, that's the common theme. We have 5 plus 3 and 1 plus 7. Great, this is fantastic. That's all doing 8. And there's like all these crowds like, ah! But, okay, so what does that look like on the abacus? Well, on the abacus, Okay, good. On the abacus, we have 7. And then my question is do we have enough to add 7? Yeah, we have enough to add 7, not a problem. Okay, what is the problem? What am I trying to do? Now, what the problem was is they started doing 4 plus 4. And we all know, like in school, because we were told to memorize what 4 plus 4 is. Okay, 4 plus 4 is 8. That's fantastic. So they're all 8. Yeah, we know that they're all the common. I homeschool. Is it hard to teach my child old math, do you suggest? What's old math? Would it memorize? I wouldn't suggest memorization. I would suggest understanding how. I would suggest like how to use the math. So that's what the abacus is. I mean, if you think, unless you consider abacus old math, then I would highly suggest it. Wasn't supposed to be there just a minute. Oh, no, you know what? Abacus is old math. And do I suggest it? I totally believe it. So I would, kindergartens could do this definitely, because what it is we were talking about like how to move the beads, and as we move the beads, it's really quite interesting. So let me continue on with my thought. But yes, you can find it on Amazon, and you could use my name to search for it. So depending on how far along your kindergartner is, if they don't know how to read, if they don't know what their numbers are, then I would suggest this. But if they already know their numbers, then we can continue on, and I'll show you more of the books. But I wanted to continue my thought on this one, just to show you the difference, right? So, oh, okay. So the thing was the question was, okay, 4 plus 4, right? We in abacus we actually don't memorize. We actually don't memorize our doubles. So in school, we tell the children to memorize our doubles. Okay, because we don't, because then there's like doubles plus 1, right? And then there's doubles minus 1. Well, those are like minus 1. So those are ways, those are strategies, which is fine. But see, the difference is in abacus we actually don't teach we actually don't teach to memorize the doubles. What we teach the children to memorize is the building blocks. What does that mean? Well, here I have 4. I'm going to add 4. Okay, this is what I did. I added my 4 on my abacus. And notice I don't have any more beads to add this 4, right? So I don't have enough beads to add the 4. What do? I actually, oh, maybe I could put it in. You can find it on Amazon. Oh, I didn't think about typing. Let me type my comment. Can I answer? I'm going to reply. Amazon. I wonder if that helps. Oops. Amazon. No, I don't know. Okay. So I'm going to continue on. So here, what we're teaching in children is we're teaching children how to make a 5. And that's one of the things that abacus really does well. Abacus really solidifies fundamentals. So what does that mean? So we have 4 plus 1 is equal to 5. We tell the children in kindergarten, how do you make a 5? How do you make a 5? 1 plus 4 is equal to 5. So, but the thing is that's as far as it goes. So the interesting thing is in abacus, we kind of go outside of this box. When we rearrange it, we're going to isolate this variable, and abacus is the gateway to complex math. So what we're doing is we're going to isolate the variable. That's a algebraic term, right? We're going to isolate the variable. What are we going to do? We're going to take this 1 and we're going to move it to the other side of the equation. So I'm going to rewrite it and put it in plus 4 is equal to plus the 5 minus 1. When I plus the 4 minus the 1, why am I doing this? Because it's a fundamental formula that we need to memorize. This is what the kids need to memorize. The kids need to memorize this. I talk about this because I wanted to tell the parents, right? I'm telling adults what we're trying to do here, because as an adult, I want to know why I'm doing it, because you ain't telling me nothing until you tell me why. So this is why, right? What we're trying to do is we're trying to isolate the variable. Because what we want to do is once we isolate this variable, we're going to substitute this information into here to be able to work the abacus. So when we substitute this information, I say plus the 5 minus the 1. The reason why I say plus 5, I say plus because I want to add the 5. As I add the 5, I want to take away the 1. So what I'm going to do is I'm going to add the 5 and I take away the 1. So now my answer is 8. So going through this, in abacus, we don't memorize, we don't look for the common answer. What we look for is the common add-in. So this adding would not be with this as I teach the children, right? So that's why when I created this book, it was specifically to the add-in. So as we go through this, I wanted the children to see what it would look like to add the one. Why? Because I want to put in the different scenarios and see what it looks like. So here I have 7, so I have 7, and then I add the 1, and I add the 1, and my answer is 8. Oh, I already did that. Anyways, so then I have 2, right? I have 2 plus 2. The reason why, I mean, it's easy for us. Why do I want to go through it? Because I want to show and see what it would look like on the abacus. Because it's different when we imagine the numbers in our head. Than it is to put it in our head. So when I see the numbers, right? If I do this one, let me do this one. This one is 8. How do I know it's 8? Because I'm going to count 5, 6, 7, 8. Another thing that abacus does, it provides, it introduces the concept of counting on in class, right? Because now we're going to do 5, 6, 7, 8, and then plus 1, right? And that's what gives me 9. Now, counting on is a kindergarten skill. You could start counting on anywhere, but abacus introduces counting on early. Because we have to go after 4, we need to figure out how to do 5. What is counting on? Counting on means counting not from 1. So oh, hey, lady. Welcome back. We're counting on the abacus. We're doing adding and subtracting. So again, and what I've also noticed is as we count like plus the 1 and then we do plus 2, right? Understanding that when we do 2, it's these 2 beads. It's not just the 1. It's actually 2 beads, right? These 2 beads or these 2 beads. So now what we're also showing is number patterns. On the number patterns, that's what we're doing is the number patterns. Okay. And then I heard somebody told me, I can't remember now. Somebody told me that now in kindergarten they teach children how to subtract like the second half of kindergarten. And I'm like, okay, but in abacus we actually have to teach it right away. We have to teach it right away. Why? Because our formulas have a lot of adding and subtracting. And the difference between the two, what's the difference between the two? We know in abacus, when we subtract, we're taking away from the horizontal bar. I'm sorry, I was trying to read the abacus. I'm trying to read the comment, and then I was trying to think what I was trying to say. Okay, how do you explain to children why they add the different beads? Like when you isolate. I don't, actually. I don't explain why we do the formulas, because they don't care. Okay, so this formula, they don't care. What I would do is I would make it into a story. And so that's where, that's where it is. So that's where this would come in. So why would I do that? Because they like stories more. So this one, so we're going to talk about the 5. Let's talk about the 5. And so one of the stories I have, like to get them to remember, they don't care why. They don't care why. Honestly, they don't care. I've been teaching for 20 plus years. Nobody said, why are we adding the 5? They just know that we're doing it. So here is the story. And one of the stories is the 5 of the cats, the 5 cats in a tree. Why are there cats in a tree? Because cats like trees. And I was just trying to make it easy for the kids to remember how to do the formula. So when we're doing 4, right? We have 2. We add 2 on the abacus. Can you say the values of the beads? Yes, Charlie, I will. Division, please. Yeah, okay. We will try to get to division depending on how everything is. So, but I do want to do multiplication if I can. But I do have a hard 45 minutes because I have class at 9. So, Charlie, the beads, the values of the beads is all these are values of 1. So we have 1, 2, 3, 4. So I'm trying to add 4. Now the value of the toppy will always be 5 no matter what. No matter what. But now when we talk about it, why are we here? Because I call this as the ones place. There's a dot right here. This is my ones. And the other reason why I'm doing it over here is because it's just easier to see. Right. You could do this one depending on how big your numbers are. You could do this dot if it's over here. So we do ones, tens, hundreds, thousands, 10,000. Yeah, not a problem. So going back to here, here's my question. I have 2. So why do I want to add 4? Well, notice That's just a question. That's okay. But I can't see it, right? I don't have enough beads to add the 4. So what do? I have to go to the cats in the tree. Why am I going to the cats in the tree? Because I want to know how to add a 4. It's possible, but how do I add the 4? So if I go to the cats in the tree and insiemias, I would use my fingers, right? I would go to the cats in the tree, I would touch the 5 bead, and I grab 4 cats. When I grab 4 cats, right, I touch it and I bring it down. I bring down the 5 bead, and then 1 cat runs away. So 1 cat, which is the 1 bead, runs away. If that makes sense. So showing them this, that's what I would say. That would be something that they would have to memorize. Yeah, like I have students, they're going through it right now and they're like, okay, and I would show them another scenario, right? So I'm going to add 3. If I add 3, how do they remember it? I would use my hands. I would use my hands and be okay and go to the cats in the tree. So how would they remember it? They remember the cats in the tree. They go to the cats in the tree and they grab 4 cats, right? And then they would see that 1 cat runs away. That would be how they would remember it. You would have them also say it out loud. Plus the 4 is equal to plus the 5 minus 1. As you have them say it out loud, they will start to remember. It would take time. I'm not saying it's going to be like right away. It took my kid the longest time. He had such a hard time. But as he would say it more and he talks about it, he would remember it. Ask him now, he doesn't remember it. But when I was teaching him, I had to get him to say it out loud. And the one student I have right now that's going through this, he remembers cats in the tree. So he would remember, okay, I got to go if I'm doing 4 and I need to add another 4. Let me move this up. If I have 4 and I need to add another 4, I need to go to the cats in the tree, add the 5, and 1 cat runs away. That's how they would remember it. Other ways would be they have to say it out loud. Make sure that they say it out loud, because if they keep it in their head, they can't vocalize it. And even when I say it, I have to remember. When I say it, I remember when I'm trying to do it. I hope that helps. So that is about adding and subtracting on the abacus. Okay. Any other questions? So when we come, just to a little review. To count on the abacus, it's 1, 2, 3, 4, and then 5. The top bead will always be 5, and then we have 6, right? Because we have 5, 6, 7, 5, 6, 7, and then 8, 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. So did that make sense? I don't know if she's around anymore. Michelle. So Michelle, did that make sense about is it hard to teach? It's not hard to teach. It's not hard to teach abacus. It's simple to use, easy to understand. Easy to understand, simple to use. It's just one thing is we just need to know how to do certain things. So even with this, oh yeah, in CMS, when we do it, do they know how to make a 5? So Icarus says, so plus the 4 is minus the 5. So adding the blue bead is what I said, the cat's in the tree, and then 1 cat's run away. So the difference is, yes, so it's plus 3. Yes, to add the 4. Exactly. Grab 5. No, not grab 5 cats. It's grab 4 cats, because you grab 4 cats and 1 cat's run away. You grab 3 cats, 2 cats run away. It's not grabbing 5 cats. You go to the trees and you grab the cats. That's what it was. That's what I was thinking. Hopefully that makes more sense. But yeah, you go to the tree, right? When you go to the tree, that's when you add it. And you grab 3 cats and then 2 cats run away. And then my answer is 6. So if I had 3, yeah. So that was the thing. Is like you go to it, right? You go to it, that's the 5, right? You add the 5. And then you grab 3 cats. So you take 3 cats, but 2 cats run away. Yeah. Because, I did this because, or else we had to get the kids to memorize this, and they don't know why. And and I noticed that it's a lot harder, not harder, but it takes more time if they just do it this way, as opposed to understanding that you go to a cat's in a tree. You could say anything, really, right? But the idea is, do you have any students that feel formula helps them understand more? Yes, I have 20 plus years of experience of teaching children how to use the abacus. And when they reflect, when they're older, I had some children that has graduated to like college and all this and that. And but when they reflect, and then when they reflect, they realize that it's it's more solid. So learning this way is more about filling in providing a foundation, because there's no memorizing the doubles, there's no memorizing the strategies that's being taught. It's memorizing the fundamentals, it's memorizing the building blocks. When you know the building blocks, then it just compounds on top of everything. And then as it compounds, then it's easier. Instead of struggling with multiplication facts, we actually do multiplication. And so because we go through adding more foundation and packing it to be more solid, it's a lot easier for the kids to do more complex math. So when my kids were going through it, I have three boys. They've all finished abacus, and when I talk to them, because I can only talk to them, right? No, when I talk to them, they realize that it provides them a stronger foundation. Do they know? They don't know, but I see it between their friends and them that they actually understand what's going on, but they don't know why they know it so well. So my kid was going through algebra, and he's like, I know it, but I don't know why I know it. And I told him the reason why you know it is because what we do here is we isolate variables, and then what we do is we substitute. So when we substitute, we don't say it in abacus because it doesn't make sense to say it in abacus. We just do it. But the reason why I'm here and I have my lives is so I can explain to adults why we're doing it and what we're trying to do. So there's many things that we do in abacus that we don't actually say, like distributive property. I know there's a lot of there's a lot of terminologies in there's a lot of terminologies that math does that we don't do in abacus, because we just talk about the basics, which is plus the 4 is equal to plus the 5 minus 1, and that's a fundamental thing. We in school we're given an addition table, right? I heard that the 5 is the boss. Ha! And the 4, hey, that's a good one. And the other beads are employees and their friends. Yeah. So so that was the other thing, is like the 5 is the boss, but then there's also a 10, right? So okay, going back to this thought process. We have an addition table. We're given I don't know if we're given addition tables to school anymore, but I remember seeing the addition table, and it was a little confusing because they would have like rows and columns, but there was no sense in it. It was just like, okay, this is how you add, this is how you add. But in abacus, it's different. Why? Because the way I had color coded it, this color is all simple. Simple means that if I add the 5, do I have enough to add the 2? Yes, I have enough to add the 2. Now, when I get to here is what we do the 5. Yeah, the 4 is the friend of 5. Yes. 4 is the friend of 1 and 2 is the friend of 3. So that's the common thing in abacus, right? If you talk to anybody in abacus, we know that 2 and 3, we have 4 plus 2. Do we have the question is there enough? Is there enough to add the 2? No. How do I add the 2? What do? Well, I go to the cats in the tree, go to the 5, I grab 2 cats, and 3 cats run away. But they have to remember that 2 and 3. So in school, we are already teaching children how to make a 5. So we're already teaching the children how to do plus 2 is equal to plus 5. Sorry, 2 plus 3 is equal to 5. We're already teaching this. Abacus leverages this concept, if that makes sense. So it's so interesting because, and then it's just so interesting, like we only stop it here because there's no other tools that will help us solidify how to make a 5. We do many things to show how to make a 5, right? We have these bricks, cubes. We have these cubes, right? And we show them, okay, these are the 5, right? 3 and 4, and then that's it. But in abacus, we take it one step further. We do substitution. And that's when we do the 4 plus 4 is equal to 5, right? So then the next one in CMS, I don't know if they call it big friends or small friends or they call it family. So the next one over would be how to make a 10. wait, I'm sorry. Before we do this, right, before we do this, we need to remember how to minus a 5. Because if we add a 5, we minus a 5. Why? Because we need to learn when we do 8, how do I minus 4, right? So when we minus in adult eyes, it's 4 minus 1 is equal to minus 5. This is not negative. This is learning to take away. So when we yeah, the Boston small friends. Okay, so they're doing small friends, big friends. Some people, some places they do friends and family. In that, and yeah, some places they call about plus fives and or the plus fives and plus tens. Oh, I sit and watch. Yeah. So going back to here, when we teach them how to do the plus, you need to teach them how to do the minus, because when we start doing the minus, like even right here, we have to show them how to minus. So now taking away is or just part of the process. So we after we know how to add the 5, we need to learn how to minus the 5. So again, the same concept for us is we take this 1 and we move it over here. Why? Because we want to take away the 4. Right? We're looking at the second add-in. When we look at the second add-in, we want to take away the 4. When we want to take the 4, we have to we're going to rewrite the equation. Rewrite the formula. Minus the 4 is equal to minus the 5 plus the 1. What do? We take away the 5 and we add the 1. This time I use pots in a flowers in a pot. I don't know. But I haven't written that workbook yet, so I'm trying to figure out that one. No, I have my classes, they're already doing it. I just haven't created my book yet. But that's what that is. So again, if you notice, right, the 4 and the 1 are pairs. The 3 and the 2 are pairs. So just like this, right, we would rewrite it. Everybody would know that plus 3 is equal to plus 5 minus 2. And then there's the other side, right? There's the inverse. Minus 3 is equal to minus 5 plus the 2. So when we look at it, we solidify it. I don't know. I'm so sorry. I don't know if that made sense, Charlie. I just kind of went down a tangent. But yeah, I do believe that abacus is the greatest thing next to sliced bread, and I do believe that the kids really understand it. Okay, great. Or maybe it was just long-winded. Anyways. Okay, yeah. So we learn the 5, and then after we learn the plus 5, we do the plus 10s, right? So what is a plus 10? Plus 10 is making the 5. Plus 10 is, no, I'm sorry, making the 10. So in school, we're teaching the children that 9 plus 1 is equal to 10. We're teaching them that 8 plus 2 is equal to 10. Not a problem, but that's as far as I go. I have higher math understanding, so you can explain however. Right, thank you. Okay, great. So we have this, right? Not a problem. So we're going to continue on with just doing some adding. So we have, one of the questions one of my parents had was, well, I want my kid to know what 8 plus 5 and 5 plus 8 is. And she's like, isn't that the same? And I'm like, no, it's not the same, because now we're starting to deal with two different stages of abacus. Why? Because, okay, so the first thing we're going to do is we're going to look at it on the abacus. This is different. Why? Because it's the second add-in. The second add-in is what makes it the difference. So when we add 8, we have 8. Right? Not a problem. Now we have 5. Well, is there enough beats to add the 5? No, there's not enough beats to add the 5. What do? Well, just as we know how to do 5 plus 5 is equal to 10, we can rearrange this to say plus the 5 is equal to plus the 10 minus 5. So again, I plus the 10. When I plus the 10, when I plus the 10, this is the beginning of carrying over the terminologies of carrying over and regrouping. In abacus, it only means go to the next column. That's all it means. As simple as it is, that's all it means. So I could be like, let me continue on. I could be like 80 plus 50, right? We don't say add 100. So if I'm here and I add 80, so this is 80, and then I add 5. No, I'm adding 50. I'm here. When I add 50, I have 5 and 0, right? I'm adding 5 and 0. Now, I don't have enough beats to add 5. when I do this, it's plus the 5 is equal to plus the 10 minus 5. We don't say in abacus plus 50 is equal to plus the 10, no, plus the 100 minus the 50. We don't say that. We boil it down to its simplest form. Our simplest form is plus the 10 minus the 5. So what I'm going to do, I'm going to plus the 10. So I just go to the next column over. I plus the 10 and then I take away the 5. Okay? So my answer is 13 because I'm going to take away this, right? So that was doing the making of a 10. When we make a 10, we utilize the 10 pairs. So again, the 10 pairs is a 5 and a 5 and a 6 and a 4, right? To make a 10, 7 and a 3. This is all the 10 pairs. These are all the 10 pairs that we need to memorize. So here's my next question. Well, can I just add 5 and 8? Well, no. Why? Because now when we add the 5, we want to add the 8. Well, okay. How do we add the 8? Is there enough? No, there's not enough to add the 8. What do? How do I add the 8? So remember, plus 8 is equal to plus the 10 minus 2. So I'm going to go to, remember, this is plus 10. So plus 10 means I go to the next column over and I plus the 10. So I'm going to add the 10, and notice I cannot simply minus the 2. So if I cannot simply minus the 2, how do I do it? Remember, we were talking about when you know the 5, you need to know the minus 5. So what is it? Minus 2 is equal to minus the 5 plus the 3. That's the pair, right? So when we do this, can I take away the 5? Yes, I can. How do I do it? I take away the 5, right? What I'm going to do is minus the 2 is equal to minus the 5 plus the 3. So I minus the 5 and I plus the 3. So now my answer is 13. The goal is the same, right? The answer is the same. The result is the same, but the process is different. So that's why we have to tread lightly when we start adding and subtracting on the abacus, because there's different ways of, there's different methods, there's different ways to add the building blocks. The building blocks is all you need to know is you just need to understand the 5 and the 10s. Once you understand the 5s and the 10s, everything else is golden. Why? Because now what we're going to do is we're going to start doing two-step equations. And this is the introduction to two-step equations. So, and this is what helps understand higher thinking math, right? So we're talking about basic arithmetic. We all need to understand basic arithmetic to get to the higher complex math. Does it do algebra? No, it doesn't do algebra because we don't take out anything, right? But it gives you the foundation, gives you the foundation, the framework of understanding how to manipulate your numbers and how it all interjects. How does it all fit to how many pieces does it fit together, right? Just like how I have these blocks, right? And then I have other blocks. So they're teaching in school. I'm not knocking it. What I'm saying is it's like just like they're teaching blocks in school. Well, we're showing blocks in school, and it's the same thing with abacus. We have our fundamental building blocks, which is the making the 10 and making the 5. So that's what adding and subtraction is. I always say knowing the fundamentals can help you solve anything. Yes. So an interesting thing is that it's exactly because when I started going down this rabbit hole, and I'm trying to find my paper. When I was going down this rabbit hole of like, what does abacus do, and why isn't it more common in mainstream school? Well, the reason why, because we don't use these terminologies. We don't use terminologies like the 5 frame and the 10 frame. We just say friends, big friends, small friends, plus 5, minus 5, right? We don't say distributive property in our in multiplication. We just say multiply, and it's really interesting. So we don't talk about substitution, but we do, right? We don't label it, and that's what I'm starting to do. Is I'm starting to label what we do in abacus, and there's a lot of similarities in abacus and how it is really just the foundation, just building a foundation. And so that was the thing, is like, you see the kids doing all this, crazy, number fingers, all this and that. What they're doing is they're doing abacus in their head. Now, if it goes through, like once they understand the foundation of adding, subtracting, we can go into multiplication, division. Why? Because multiplication is just fast adding. The one thing that abacus does not do is it doesn't show you how to do multiplication facts, right? That's something that we have to learn. That's something that we have to memorize. You could do multiplication facts on the abacus as cumulative, right? So what does that mean? Well, we could do like 6 plus 6 plus 6, right? You could do that. I had my kids do this and they got tired and they started memorizing their multiplication facts. But I would start what I did in my school, in my classes, I got them to just kept doing this and until they started seeing it. Why are you starting to count a second? Oh, the reason why is because I have this dot. This dot tells me that I want to signify that my place value is where the dot is. So you can choose any dot. I just chose this dot because my abacus was hanging out, but you can choose any dot, and the dot helps to label where everything is. So if I start here, I know that this will be my thousands. That's just how it is, right? So if I have a bigger abacus, like this is a 13 column one, if I have my bigger abacus, the way the dots are positioned, they're grouping. Oh, I forgot the terminology. They're grouping they're separating. They're separating the groups. So we have our ones and our thousands, and then this is our millions. So when I count it, it's ones, tens, hundreds, thousands, 10,000, 100,000, and 1 million. So it doesn't matter what dot you want to use. It just matters where you want your ones to be. So that's why I did it over here, just because it was just easier to see. So now I'm going to be over here. So here I would get my kids to be like, okay, 6 times 1 is 1. So I'm going to add the 6. 6 times 2, right? And they see it. 6 times 2 is 6 times 2. How do I add 6 here? Oh, yeah, no problem. Let me know if you have any other questions. 6 plus 2. Now I want to add 6. Is there enough? No. Plus 6 is equal to plus the 10 minus 4, right? So plus the 10. So I'm going to plus my 10, and I take away the 4. Again, I cannot see that. Take away the 4. Minus the 4. Can I take away the 4? No. What do we do when we want to minus the 4? I need to minus the 5. So minus the 4 is equal to minus the 5 plus the 1. See how it kind of adds to it, right? It adds to and solidifying. So now we are no longer using working memory. We're using long-term memory. So we're going to minus the 5 plus the 1. Notice I have 12. I am over here. I'm going to add 6 again. The question is do I have enough beats to add the 6? Yes, I do. I'm just going to add 6. So I know 3 times 6 is 18. So in abacus, we don't do multiplication facts, but you can do additive. And that would be one of the things, just to get them solid. So as you know your 5s and your 10s, then you're golden. All right. Okay. Anybody else have any other questions? We're going to go into multiplication. And multiplication we're going to do is distributive properties. I don't think, Lady E, I don't think we have enough time for more division. Because I'm going to be leaving in about 25 minutes. Yay. All right. So one thing is in abacus, we don't memorize anything higher than 12. Just so you know. We don't memorize anything, but we do memorize our 9 times table. Everything up to 9 times table. So one of the questions, let's do this. Let's do something easy, because let's do 12 times 6 to evening. Yeah, I'll probably come on later on tonight. I think I will, because I don't think I have too much. I think I will. After I have my class and then work on my book. I was doing some research yesterday on how to make a 4th grade book for abacus, and I was like, this is going to be easy. The reason why is because we do a lot of fundamentals, but I noticed in abacus, we actually don't categorize it how we do it in mainstream math. And so then if I started to just kind of block everything, it was just an interesting epiphany. Okay, so going back to here, what are we doing? We're doing multiplication. When we do multiplication in school, mainstream school, what we do is we line it up like this. 4, 12, and then 6, and we line it up like this. Right? As we line it up, I noticed that in mainstream math, they do this first. This is the first one they do, and then they do this one, which is the second one, right? This is the second one, which is fine, but we don't do it that way. In school, in abacus, what we do is we figure out what our place value is. So the first thing we need to do in abacus is we need to know where our starting point is. So the first thing we need to do is our starting point. Starting point. I don't know. That's all we call it. Where are we going to put our answer? That's the thing, right? Where are we going to put our answer? So what I'm going to do is I'm going to count my digits. 1, 2, 3. So I have 3 digits. So that means I'm going to start at the hundreds, because when I count it, my ones, right? 1, 2, 3. So here is where I sit. It sits on the hundreds. When you look at it, you're like, wait a minute. That's not going to be it's not going to be a hundreds answer. You're right. Because, I'm going to put my finger here. Because what happens is when we do 6 times 1 is equal to 6, 6 is a single digit. So what I'm going to do is I'm going to go back one column and I'm going to add my 6. So that's how I add my 6. And then 6 times 2 is equal to 12. So all I got to do is add my 1 and my 2. So I have my 1 and I have my 2. And that is my answer. My answer is 72. Yeah? It's different here, right? You could do it this way, but it gets confusing because in abacus we do more than just the 2 digits. So here, when we do it, we have 2 times 6 is 12. So notice my finger is here because that's where it starts. It starts on the ones. But because I'm adding 12, I got to go one step forward to add the 12. 1, 2. Now my finger is here, and I want to go here, right? 6 times 1. 6 times 1 is 6. 6 is a single digit. 6. That doesn't look like 6. 6, right? Can you do it with more digits? I find it more difficult. Okay, yeah. So I have 6, right? So I need to know that I got to go forward to add my 6. So that's what it is. Okay, so something more difficult. 2 digits. We'll do. Oh yeah, the question was 2 digits, right? So let me. I'm just looking for questions. I don't have a lot of questions. Oh, hold on. Maybe I'll do this one. Here. No, I don't like those ones. Sorry, I'm looking for questions. Okay, this one. So we have 88 times that by 37. Okay, 88 times that by 37. Okay. I believe this is now considered 5th grade math, if I'm not mistaken, because now we're doing more, right? That's what I'm assuming. I have to do more research on my grades. Again, so the first thing we need to do is we need to find our starting point. 1, 2, 3, 4. So our starting point is 4 because we're counting the digits. So we have 1, 2, 3, 4. I'm going to start at the thousands. That's what, the 4th column is because I start here. Not a problem. So that's my starting point, right? My starting point is up there. I don't need to, anyways. So the first thing we're going to do is we're going to go 3 times 8 and then 3 times 8 again. Maybe I should have changed a different number. That's fine. So 3 times 8 is equal to 24. So notice I add 20 and I add 4. So I add my 2 and I add my 4. And then I do it again, right? Middle of 4th is when they start learning to. Oh, okay, that's good to know. So we're still doing 4th grade math. So here, I want to do it again. So I already did my first 8. Now I got to do my second 8. I want to add 2. I want to add 24. 24. I want to add 2. To add the 2, right, is plus the 5 minus 3. So I plus the 5 minus the 3, and then that's my 2. Hopefully you guys can see that. That's my 2, right? Now, now I add my 4. So I go to the next column and I add 4. Can can this, after this, can you do 7th grade algebra? No, not on the abacus. Abacus only does arithmetic. So as far as we go to decimals and division. I actually don't do algebra. I don't do algebra. All right, so we're done with the 3, right? Because we've already done 8 times 3 and 8 times 3. That's all we did, right? So we have to reassess. We have to reassess how our next starting point. How do I do that? I just take the 7 and then that's 1, 2, 3. So after that I do 1, 2, 3. So I just count. I start again. 1, 2, 3. So I'm here. So the question is 7 times 8 is 56. So I add my 5 and I add my 6. So now this is where it gets a little complicated because you need to know, you really need to be solid in your formulas, right? So I need to add 50, I need to add 6, I need to add 5. Plus the 5 is equal to plus the 10 minus 5. So I'm adding 50 here. So I plus the 5 plus the 10 minus the 5. And now I need to add 6. So this over here is my 6 is plus the 10 minus 4. So I plus the 10 and I take away the 4. So I plus the 10 and take away the 4. That's the 1. That's 1, right? Now we're going to do it again. The reason why I'm writing it out is so we can keep track. So this is the second time we're going to do 56. So all I got to do, is there enough to add 50? Yes. Is there enough to add 6? Yes. So my answer is, anybody see what my answer is? Does that make sense? Yeah, so in the comments, put in the answer what we think this is. Oh, excuse me. Do we make sense? So if this is my ones, my tens, my hundreds, and my thousands. Yeah, that makes sense. Thank you. I fully understand it. Oh, fantastic. Yeah. So here's my answer is 3, 3, 2, 5, 6. I do it this way so then I know where I put and then I would say it out loud. 3,256. Can I read it from here? I could, but it's just easier to write it out, right? Because now we have it. Anyways, so I mean, okay. If we're okay with that, then we can do division. We can do another multiplication, or we can do division. What do you guys think? Okay, we're gonna do division. All right. Cool. Division. This one's a little bit higher math. Is it higher math? That's not higher math. It's all the same. It's super easy. Simple to use, easy to understand. All right. The way we're going to do this one is 3. That's not 3 divided by 9, 7, 5, 9. We can do this. Not a problem. Now, why is this a problem? No, it's not a problem. I don't know what grade this is. I'm assuming that this is grade 5. I don't know. I'm still trying to figure out my grades. We could do it this way. 9, 7, 5 divided by 3. We could do that too. Not a problem. It doesn't matter. Because it doesn't matter. Okay, well, you know what? We'll do it this way to show the long division. Okay, we'll do it that way. First thing we need to do is we need to figure out where are we going to put our answer. The reason why is because we don't just put our answer here, right? What we do, because this is the ones, I don't know how big this number is. So what we need to do is we need to have a conversation with our question. Our conversation is how many beats do I have? So I have 1 here and I have 3 here. 4 take away 1 is equal to 3. This is where, on the third column, is where I'm going to put my answer. So I'm going to count 1, 2, 3. This is where I'm going to start with my answer. The next thing I need to do is I need to put my dividend. I'm going to call it E because they both sound the same, right? Dividend and the divisor. I'm going to say S over here. So this is the dividend. So I'm going to put my dividend next to here, because what I want to do is I want to keep a running total on how to take away. So again, my third is where I'm going to put my answer. I'm going to put my dividend on my abacus. So I'm going to put 9, 7, 5, 9. Now what we're going to do is we're going to compare. Why do we compare? Because we need to know if we have to take away 2 digits or 1 digit. Why 3? Because I have 4 digits here and I have 1 digit here, and because we are doing division, we're going to take away we're going to do a takeaway. So instead of in multiplication we add our digits, in division we take away our digits. So that's why 3. Okay, so the next thing we're going to do is we're going to compare, right? So we found our starting point. We found where we're going to put our answer. Now what we're going to do is we're going to compare. There's two rules. If the divisor s is bigger than the dividend, right? If the divisor is bigger than the dividend, right? Dividend. Then you take 2 columns, and you take these 2 columns. But if the divisor is smaller than the dividend, then you only do 1 column. You only do 1 column, and you have to skip this column. Where are your ones? My ones is still here. My ones is still here. So what I did is I count to 3. 1, 2, 3. This is where I'm going to put my answer. That's why my finger is here. And then what I'm going to do is I'm going to put my dividend here. 9, 7, 5, 9. Did that make sense? 7, 5, 9. Okay. Okay. So that's why I put it here, so we can do subtraction. So some of the things that we need to know, right, is if the divisor is bigger, I take 2 columns. If the divisor is smaller, I do 1 column and I have to skip a column. So I'm going to skip this column because my dividend is bigger than my divisor. Right? Because my dividend is 9 and my divisor is 3. So now what I'm going to do is I'm going to say, my question is 3 times what is equal to 9 or less? The reason why I say that is because in abacus, we don't think how many groups gets divided. So what we do is we find the missing, thank you, Lady E. We find the missing factor. So here, 3 times 9 is equal to, 3 times 3 is equal to 9. So I'm going to put my answer here, which is 3. I'm going to go back here and I'm going to take away 9, right? I'm going to take away my result. So I take away 9. Okay, so far we're okay? Now, we're going to do it again. I'm going to take my finger off and we're going to reassess. We have to compare. Why? Because I have some dividends left over. Oh, I should have not done that. Okay, so let me redo it. 3, 9, 7, 5, 9. So I have, sorry, what happens when the divisor is bigger than the dividend, you take 2 columns. So it's the 2 columns, it's these 2 columns you take. You use to as your answer here. That's what that means. So I add my 3 and I take away my 9. So what we're doing is So notice I still have dividends. Yeah. I wish they would make them better terminologies. Okay. So dividends. So I have my dividends. I'm just trying to move it up. So my answer is 3. My answer is 3. Okay, my answer is 3. I still have dividends, right? So now I got to compare. I have to compare what's there. 7, right? 7 Sorry. 7, too much. 7 and 3. I still have to do my dividend, my divisor. See, I'm getting confused with the naming. So 7, who is bigger, 7 or 3? So if I look at my chart, my 7 is over here, my 3 is over here. That means that I'm only going to be doing the 1. So I'm going to skip one column. I'm going to skip this column, and I'm only going to take away the 7 over here. Okay? So then the question is 3 times what is equal to 7 or less? We say less because, 3 doesn't go into 7, right? So we say or less. We want to be as close to the answer as possible. So it's 2. 3 times 2 is equal to 6. So I add my 2. Yes, exactly. Thank you, Lady. So I add my 2. That's my answer. My answer is 2. So, and I take away 6, right? Because 3 times 2 is 6. So I go over here and I take away 6. So I take away 6. Like that. So that's the same thing as 7, and then we do 1. Oh, I need to add my 2 here. Okay, I still have dividends. So what do? I compare. Now I have a 1 compared to 3. So if I have 3 and 1, I have to do 2 columns. So these 2 columns is what I'm taking. I'm taking this one and this one. So I'm going to put my answer over here. Because I have to take these 2 columns, I'm going to put my answer over here. That's just one of the rules. So what do? It is 3 times what is equal to 15 or less. So I bring this down to 15. So the question is what times 3 is equal to 15 or less? 3 times 5, right? 3 times 5 is equal to 15. So I add my 5. My answer is 5. I add my 5 here. And I take away 15. Take away 1, take away 5. I still have dividend. So what do? I need to compare again. Who is bigger? The 9, because that's my dividend. That's what's left over. Or the 3. The 9 is bigger. I'm here. So when I'm here, because the 9 is bigger, I have to compare. I have to use one column, and I have to skip one column. Okay, so this is the column I skip. This is my dividend. I have to skip one column and go here. So the question is what times 3 is equal to 9 or less? 3 times 3, so I add my 3 here, and I take away 9. Does that make sense? So my answer is 3,253. That was an easy one. We can do another one. All right? Does that make sense? I think I understand. Yeah. I do this to compare, but obviously we don't need to do this. We can do another one. Let's do another one. You know what? Let's do a 5. I think 5 will be easy. I wonder how many days it will take me to go through this notebook. That's my other question. How many days does it take me to go through this notebook? Okay, let's do 5. Let's do an easy one. Let's do it this way. We'll do 5, 32, 35. Right? We'll do 5 because 5 is kind of easy, right? Same thing. We have to look at our digits. We're having a conversation. We're going to be like, how many digits do you have? I have 4 digits, right? Take away 1 digit. So I have my divisor and dividend, right? I have my divisor. No, my divisor is 1 and my dividend is, okay, I got to do the S and okay. And then it's 3. So what we're going to do is we're going to go to the third placement. 1, 2, 3. So now we're at the hundreds. My answer is going to be at the hundreds, which is fine. Okay. Now what we're going to do is we're going to put our dividends. I gotta do this to remind me. So I'm going to start here on the third column. So I'm going to put my dividends on my abacus. I have 3, 2, 3, 5. Now I'm going to compare. If I compare my, I have to write it better. Anyways, so I should do it on this side actually. S and E. So who is bigger? My dividend, my divisor is 5. My dividend is 3. Excuse me. My divisor is bigger. If my divisor is bigger, then I take 2 columns. I use 2 columns. So I use these 2 columns and I put it my finger here. So the question is what times 5 is equal to 32 or less? 5 times what is equal to 32 or less? 5 times 6 is equal to 30. 5 times 6 is equal to 30, right? So I put my answer here, 6. I put my answer there. And I take away 30, take away 3, take away 0. I was here yesterday. Oh, hey! Welcome. Hearts for Sims. Welcome. Okay, so we're here. Who is bigger? My divisor is 5. My dividend, if I look here, is 2. Who is bigger? My divisor is bigger. So I still take 2 columns. So these are the 2 columns I'm going to use, right? 23, 23. Only 2 columns. We're only looking at 2 columns. So 5 times what is equal to 23 or less? 5 times 4 is equal to 20. That would be the closest. So I'm going to put my 4 here, and I take away 20. Take away 2, take away 0. I still have dividends. Yeah, that's what it is. I still have dividends. What do? Who is bigger? The 5 or the 3? Yep, and I gotta go. This is my last one. 5 and 3. 5 is bigger, so again, I just sit here and I look at my answer. I look at what times 5 is equal to 35. Because remember, because my 5 is bigger, I take 2 columns. 35. So 35. 5 times 7 is equal to 35. Take away 3, take away 5. And that's my answer. Does that make sense? Whew! There's still 13 of us. Thank you so much for follow. So yeah, we're doing division. Did that make sense? Yeah. Yes. Yeah, take it slow. And that's what it is just trying to build it out. So gosh, thank you so much everybody for joining me, because it really does make a lot of difference between how I'm going to say it when I create my books. Because this is the thing, right? The idea is, how do I convey it in a workbook form as opposed to always talking about it, So my idea was to try to make workbooks easy for everybody to understand how to use it on the abacus. My goal. Do you have division on YouTube? I don't yet. I just started. I'm going to watch your older videos to learn. I'm zero knowledge on abacus. Oh, thank you, Don. Drew says 6, 4, 7. Yes, exactly, Drew. Thank you so much. I forgot my answer. I haven't done division yet because honestly, I'm still trying to figure out my YouTube, because I'm not sure if I'm talking to adults or if I'm talking to kids, because, talking to adults and kids are 2 different things. So that's the one thing I was trying to figure out. Can you make children understand division on the back? Yes, I make the kids understand division on the abacus. Obviously, we don't take big at like this big number. We go small numbers and we grow it, right? So that was the thing. It's like just like how we do adding and subtracting, we don't go with the big numbers first. We do small numbers first, and then we start growing it. And as we grow, the numbers get bigger. But that's all we do, right? We go all the way to decimals. But yes, children do know this. Children does this all the time. My kids knew it. They can do it in their head. The idea the In the beginning, the idea was that they can do it in their head. But for me now, I just want them to be solid in understanding math. So that was the one thing. I think that my focus is making sure that they understand math as opposed to you need to be competition ready, because that's a little intimidating. Competition ready abacus is very you practice it all day in and day out. But I think for me, I just want them to understand the process and understand how to solidify like their multiplications and stuff. So that was the one thing I noticed is in mainstream math, we don't have a conversation like who is bigger. We don't do stuff like this. What we do is how many times does 5 can be divided into 32,335, 3,235, and it's kind of big. It's like really big. But in abacus, we break it down to smaller chunks, so it's easier to understand. And I think that's the difference. The difference is abacus makes it into smaller chunks, so we can digest it. We can eat the bigger elephant, right? Because how do you eat an elephant? A little bit at a time. And I think that's the one caveat that abacus does very well. It breaks it down so it's easier to manage as opposed to in mainstream math. Mainstream math is just like, well, I have these numbers, what do I do with it? So okay, so it's 9 o'clock. I do need to go. I need to get ready for class. Thank you everybody for joining. Thank you everybody for joining. But yeah, if we can get to division, that would be the end goal, is to get to division. Is it possible for kids? Yeah, my kids are. So if a student starts with me at age 3, they know how to do their adding and subtracting from 4 to 5. They know their multiplication about 5 years old to 6 years old. By about 6, they can start doing division. They can start doing division and multiplication. Okay. Yes, thank you. Goodbye. I should go. But yeah, that would be the timeline if you're looking at like at everything as a whole. Thank you again. I will see everybody on my next live. Thank you again. Oh, no worries. I'm going to be here later tonight. I'm going to go later tonight. So don't worry. We were doing division. So I will see you guys, everybody. Thank you again. Thank you again. It was just yeah. Thank you again. And I'll see everybody. Bye.